A warm good afternoon to one and all present here. Welcome to present moment as if you had invited it. Why? Because it is all we ever had. I feel so delighted to welcome our chief guest, head of the department, faculty members, staff coordinators, office barriers of all club, and my dear friends. Welcome all. A president had his task is not to do what is right, but to know what is right. Welcome for the reinstallation program of 2022 from Civil Department. I request on the dais and off the dais to stand for Tamil Thai Valthu.
நீராறும் கடலுறுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் படலமென திகழ்மலத கண்டனில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாளும் பக்க சிறு இவை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திகழ்ந்து செய்யும் பரந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you all. On this auspicious day, I would like to wish all the upcoming engineers. While the engineers have the power to do the impossible because they have the tool of science to create something new. Happy Engineers Day for all. Now I request head of the department, Dr. S. Lavanya Prabhu ma'am, to deliver the welcome address.
Good afternoon to all my dear students. Good afternoon. I would like to welcome on behalf of our department, Dr. Prabhakar sir, Chief Scientist from SERC, to our campus for first time. Thank you for accepting our invitation, sir. Here. You have come on online to the campus, I am telling, sir. Thank you for confidence. I want to first welcome all the presidents of all student chapters and vice presidents and the new office bearers. This is a very important role you are going to take today. And we have got 4 student chapters and 4 clubs. First of all, we are all in an outcome-based education system now, and every activity we are doing, we are finding the impact analysis, we are seeing what is the outcome. So each student chapter as well as the clubs have their own objective and outcome. I want to insist that all the president and the members of the club and professional chapter to work towards the activities which will bring that outcome. So please ensure that taking the responsibility is also part of it when you are going for president or vice president. That responsibility should be there, and each one has a separate outcome. Like Indian Concrete Institute student chapter And Institution of Engineers is first we started in 2013 under Dr. Neelamegam sir. He only initiated that. I want to remember him. If he is here today, he will be very happy to see all this, how much we are proceeding. He will be the first person to encourage and support us. I want to, every time it reminds me how he motivated us and supported us. So ICI, there are so many activities, workshops you are planning. Please do that. And IGBC, we wanted to start because now the world is moving towards sustainability, recycling, and not to deplete the natural resources. So we want to know what are the sustainable construction materials, construction activities. Each one, the sustainability is very important. So IGBC and Yuga Club, they are concentrating on the environmental side and the sustainability side. Today, we are celebrating, along with this reinstallation, we are celebrating the World Green Building Week from 12th to 17th. So some of the activities are for that also. And our today's chief guest also is going to share you what is the sustainable construction in the prefabrication structures. So this will be a very important and exciting lecture for us to enrich ourselves. And another club started is the Standard Club recently to ensure how to follow the Indian standards and its importance. So each club is very important. Along with that, not only what we are doing is important, how to brand that. That is also very important. Presentation and the using of social media in a right way is important. And our students are ably doing that under the civil broadcast. They bring out weekly, monthly newsletters. They have a separate Instagram and Facebook also, sir, for the department. They share what are the activities we are doing. So every club is very important. Along with that, one more club which I wanted to brief is Toppers Club. Welcome, sir. Come to the stage, sir. I welcome Mechanical HOD, Dr. Vetrivel Chirian. He is a strong supporter of us, and some of the activities we some of the activities and club activities we go in hand with the mechanical department. That is, the example is IPA, Indian Plumbing Association. That has an industry supported course also, sir. That has an industry supported course. So the industries are coming and teaching the course, not only for civil as well as for mechanical. So we have mechanical also together. IGBC, it is common for civil, mechanical and electrical. So all activities will be for the 3 branches. So like that, all this group has been formed, seeing the requirement of those groups and seeing the requirements of the professional chapter, we have started that. And regarding the sustainability, we have our students are participating in many competitions, and most of the projects, if you see, mostly on the materials, new materials. So sustainable material is very, very important for a civil engineer because we are going very close with the people around us. We are only going to facilitate the people without disturbing the nature and the natural resources is very, very important. Now, very new materials are coming without using the sand, without using the coarse aggregate like that. And concrete is having a lot of evolution. Even the cement, we don't want to use it. A new cementing material is coming up so that the carbon imprint will be less. So every day there is evolution. To update that only, we need industry people and research people to come here to share that what is happening in the field, in the upcoming materials and construction methodologies. So I once again welcome Dr. Prabhakar sir, who has readily accepted our invitation and come here to share on sustainable construction. And I congratulate all the office bearers today for the new reinstallation program. Thank you.
Thank you, ma'am. I request dignitaries on the stage to light the Kuttu. I call all the office president and vice president on the dais. I request all the president and vice president for on the dais.
அப்புறம் ஐசிஐ ப்ரொஃபஷனல் சாப்டர் கிளப்ஸ் எல்லாம்
all clubs.
last this side come this side.
Thank you all. Now I call upon Toppers Club President and Rupika to present the annual report.
A very good afternoon. It gives me enormous pleasure to welcome such a noble personality as our chief guest. Welcome, sir. I'd like to extend my warm welcome to the head of our department, our ever-encouraging staffs, and my fellow mates. The Department of Civil Engineering of Easwari Engineering College unfailingly arranging countless events, webinars, and seminars, outreaching for the benefits of students with the help of various students' chapters and professional clubs like Association of Civil Engineers, Indian Concrete Institute, the Institution of Engineers, Indian Green Building Council, Indian Plumbing Association, Youth Under Green Awareness Club, Toppers Club, Civil Broadcast, last but not the least, down to the Standards Club. Student clubs at the college are attuned to help students get most out of their experience while they are enrolled at the college for their academic pursuits. These students' clubs offer limitless opportunities for the students to develop their leadership and participation beyond classroom setup and academic program. Our department peculiarly has never failed to engage the students of civil department to associate oneself with the clubs and get advantage out of it. Not just that, these clubs also promote and invite students from other departments and colleges in the shaping of skills of students and make them life ready. In this respect, with immense delight, I'm here to present the annual report of the department. Association of Civil Engineers has never failed to surprise students year after year of our college, together with other colleges, with a big shout out, Asivara Risalto, a national level technical symposium, setting up its foundation since 2010. It aims at exhibiting the hidden talents with the students and also introduces them to recent trends in civil engineering by organizing many technical and non-technical events as well. Mounting up every year, Association of Civil Engineers has till date conducted 12 national level technical symposiums, announcing the forthcoming symposium of this year, by the mid of November. So gear up yourself, guys. So moving on to the Indian Concrete Institute. IC is one of the leading professional bodies in Indian catering to the professional needs of individuals and organizations involved in concrete. It's completely available to cause the disseminating the knowledge on concrete, research, and address the need of concrete. Nearly 30 webinars, workshops, seminars has been arranged by ICI in the chat in this duration. The talks, workshops arranged by various experts from industries and academic institutes to give a wide exposure and practicing professionals. ICI receives the Best Students Chapter Award frequently year after year. The Institution of Engineers is the largest multidisciplinary professional body of engineers, which was earlier established in the year 1920. The IE Club of our department employs to meet the goals and objectives of the club by increasing the general development of engineering and engineering science and many more. The club in the past whole year has conducted 9 events in order to encourage the students come up with their skills and talents. Some of them are quiz contests, structure with nature photography contest, quiz art series of 6 days, poster presentations, standardization of clash detention in BIM by Mr. Magendran, and whatnot, tweet the great on the theme environment. The Indian Green Building Council, part of the Confederation of Indian Industry, was formed in the year 2001. The vision of the council is to enable a sustainable built environment for all and facilitate India to be one of the global leader in the sustainable built environment by the year 2025. On that note, Department of Civil Engineering, Electrical and Electronics and Mechanical Engineering of Easwari Engineering College in concert celebrated World Environment Week 2022 from June 2nd to June 5th by conducting many events. They comprehend plantation of tree saplings in which our principal, vice principal, HODs of all departments, RGBC coordinators, student coordinators, and many students contributed to. IGBC also conducted technical quiz and video campaign on the 2nd of June and 5th of June respectively. The club organized many events from 20th September to 24th September to celebrate World Green Building Week. Digital signature, many events from organized like events of webinars, seminars, plantations, and quizzes. IGBC has also conducted 9 events for the previous academic year. IPA, Indian Plumbing Association, is a students' chapter of our department, which has conducted 11 events in total in the previous academic year, including workshop and training for MEP engineers and hands-on skill training for plumbing engineers, in which 75 plumbers from across the city participated. The club has also directed many seminars on career opportunities in MEP services and urban water management problems and prospects. Currently, IPPL is providing training and workshop for engineers for 5 consecutive Saturdays. Youth Under Green Awareness Club is an environmental club started in the year 2014 by the students of our department. The club later extended its branches to the whole college, having more than 200 students, and has been proactive club over the period of 4 years. Youth Under Green Awareness Club has conducted 3 activities in the senior year, including Music Quest, awareness on plantation, and workshop on carbon print awareness. An energetic and professional club, the Net of Civil Engineering, initiated by the HOD and the coordinator, Mr. Lenindal Sir, Toppers Club meant for the high tiers. This club functions on the module of group and groom, where we aim at taking the better to the best. It creates an internal competition among the top students. The objective of this club is to nurturing and questioning the young mind and to inspiring the top students with a quest for challenge. The club consists of all the top scorers from all the years of the department. Every semester, many informative programs are being organized by the club, which gives an exposure to top students. Toppers Club has also organized nearly 30 international webinars and 20 national talks on both technical and non-technical events. Many professionals and eminent persons from different parts of the world has shared the session. Some of the countries include US, Australia, London, Belgium, and Canada. Every year, the outreach of the program is measured with students' performances. Department of Civil Engineering came up digital media team in the tag of civil broadcast in the year 2019 to 20. Digital media facilitates social interaction, empowers people, and connects them in ways never before possible. Pandemic period lucidly made us discern the importance of digital media team as it bridges across time and distance. The main motive of this club is to spread and popularize the name hashtag SRM Easwari Civil to the faculty community, student fraternity, and as a matter of fact, to the common public. The club owns a Facebook, Instagram, and a Twitter account in the name SRM Easwari Civil Official with more than 800 followers and a YouTube channel of 1K followers. With the increasing number of followers and subscribers, hashtag SRM Easwari Civil reaches zenith in means of branding and popularizing events. The Broadcast Club has even conducted many events like magical frames and photography contests. Standards Club is a recently established club of the department inaugurated on the 3rd of June 2022. The impulse of this club is to impart knowledge with a motive to orient attitudes of young generation for students' growth and to inculcate standards culture to synthesize students on the impact of standards on life and society. So the Department of Civil Engineering has never failed to encourage students into all of these clubs and always coming up with a very good event on both technical and non-technical aspects. Thank you.
Thank you, Rupika. No man will make a great leader who wants to do it all himself or to get all the credits. Now, I request Chief Guest to present the badges for President along with the Vice President for our respective clubs.
Now I introduce the President and Vice President of Association of Civil Engineers, President Srm Vice President Michael Castro. I welcome all the team members and staff coordinators on the dais.
கீழே விழுந்திருக்காங்க தான் அட்ஜஸ்ட் பண்ணிட்டு இருந்தான்.
Now I introduce the President and Vice President of Indian Concrete Institute, President Vignesh K, Vice President Kartika A. And I welcome all the team members and staff coordinators to the panel.
அதை நல்லா சொல்லிட்டு இது பண்ண டக்குன்னு
Next to institutional. Yes.
Thank you all. Now I introduce the President and Vice President of Institute of Engineers, President Stella Nancy A, Vice President Harish Raghavendran B. I welcome all the team members and the staff coordinators to the dais.
அரேஞ்ச் பண்ண சொல்லு டக்குன்ட்டு இந்த பின்னாடி நிற்கிறான் பாரு லாஸ்ட்ல அந்த சைடில் நிற்கிறது அரேஞ்ச் பண்ண சொல்லு ஃப்ரண்ட் மூவ் பண்ண சொல்லு இந்த சுரேந்தர் சார் சைடில் ஃப்ரண்ட்ல அந்த சைடு ஃப்ரண்ட்ல அங்கே எவ்வளோ இடம் இருக்குது அந்த இடத்துல சும்மாவே நிற்க சொன்னால் தானே தெரியும்.
Thank you all. Now I introduce President and Vice President of Indian Plumbing Association, President Yugesh V, Vice President Pavan Raj N. I welcome all the team members and staff coordinator Amala ma'am to the dais.
தள்ளி விட்டுறாங்க தம்பிங்களா. அரேஞ்ச் பண்ண சொல்றா, அப்படியே டக்குன்னு அரேஞ்ச் பண்ணி வைக்க சொல்றா. மாஸ்க் கழட்ட சொல்றா.
Thank you all. Now I introduce President and Vice President of Indian Green Building Council, President Hemachandran SB and Vice President Harshida R. I welcome all the team members and the staff coordinators to the dais.
அவங்க தோட்டம் போன அப்புறம் போவேன், அதை நான் தான் பாதுகாத்தேன். நான் சொல்றேன்.
Thank you all. Now I introduce the President and Vice President of Standards Club, President Nixon M, Vice President Guna R. I welcome all the team members and the staff members to the dais.
அதான் அப்படிதான் வரணும். அந்த எக்ஸ்ட்ரா சேர் இருந்தால் எடுத்து போட சொல்லி அடுத்து நிற்க சொல்லி ஸ்டேடியம் அடுத்து டேய் அந்த கேப் எல்லாம் ஃபில் பண்ண சொல்லு. பின்னாடி நின்று கேப் எல்லாம் இருக்கு ஃபுல்லாக.
Thank you all. Now I introduce the President and Vice President of Standards Club and Yuga Club. Now I introduce the President and Vice President of Toppers Club, President M. Rupika, Vice President Srm. I welcome all the team members and staff coordinators to the dais. Thank you all. Finally, from the civil broadcast team, I call final year Perumal Das, third year Tinu Yukesh, second year Siddharth to receive the badges along with the team members and the staff coordinators. Thank you all. I wish all the very best to the President, Vice President and all office bearers.
Now I request Mechanical HOD to deliver the presidential address.
Vanakkam and happy afternoon to all of you. Out of the blue, Civil Madam has given an opportunity to talk. I do not know what means. Anyway, so since you are all taking up the responsibilities of running the show for the next one academic year, my request to this, particularly the Toppers Club, is you can look at GATE and GATE-like exams as one of the options in your club activities, because people do not see the government sector as a potential employability sector itself. The start salary is only very less, 75 to 80,000 only, whereas in TCS it is 25,000 and 30,000 start. There is a small difference only of 50,000. We are what I call logged into the mode that TCS, CTS and Cognizant are the only big brand employers. Silent killers are the Indian public sector. You do not know. They are making waves now. They are the brand ambassadors for India. Tomorrow they may even become privatized also. You never know. It could be quasi-government organization later. But they are the nation builders, like the National Highways Authority of India. These are the sectors where you should be in the future. So that is all something I think I request Lenindal, I think he's the coordinator, look at that as an option for your children. And also there is something called the, I don't know whether it's applicable to you, the engineering services also is one of the options. So these are examinations which are, you are writing a subject called comprehension now. That is the takeoff from which you can take inspiration and go up for that and look at this as an option. I do not know, no placement officer, I think in Tamil Nadu has the public sector as their priority. They only have these brand names as their priority. I request at least the civil engineering department and mechanical engineering students who are here to take the public sector equally seriously also, because colleges cannot organize those things in campus. They are always 100% off campus and all India competition. There is one paper called Employment News. I don't know how many of you know such a paper is there in existence. Like all your Deccan Chronicle and other papers which are popular among the youth. You can also look at Employment News also as an option. All the UPSC, that is the Union Public Service Commission, related recruitment process comes in that. And also Times of India on a particular day and Hindu on a particular day, they give exclusive things for this employment among the public sector and other major advertisements. So you can look at those things as an option. Also the placement coordinators for civil can take this as a priority, and also request the mechanical also, I have already told them, take this as a priority and push the students. It is slowly you can do it. The exams start only after your final year is completed. You can also attempt this year, but if you are not able to, you can always, during the next year, wherever you're employed or not, you can take up those exams. Those are really the competitive exams are also a way of getting the employment. But majorly, there is another way also. You can qualify for GATE, even with a minimum score. That is a GATE. The word GATE, I do not know whether it is accidental, they coined the word or what. It opens the gate to the public sector and the research organizations in India. So the civil engineers are those people who directly touch human lives every day and ever since mankind existence and to its existence. Civil engineers part is going to be a vital one. They touch the lives of people every day, just like the mechanical engineer. We are sitting in a room where it is air conditioned. The role of the civil engineer and the mechanical engineer and the electrical engineer are all together putting a smart building in place, making it really smart, sustainable, and making it comfortable for we humans to exist. So these things are the future employment where you will not have a single volt of electricity being supplied to the building, nor a single volt of electricity being wasted. Not a single drop of water coming into the building or going out of the building. Everything, and no waste generated at all. This is the concept towards which the world is going on. Now we as engineers on this day of Engineers Day should take this also as an option. And if not this, you can also become the easiest thing for the civil engineers. If at all we can say, these are the core three branches which started off engineering. These are the real, the entrepreneurial skills are being imparted. I do not know, I am really envy Dr. Lavanya Madam for putting in so much effort. She has got the least strength of faculty in the entire campus, but the highest amount of productivity by way of activity and other things going on. So you must be extremely lucky. I don't know how she gets that energy in the team, get them to work every day, something or the other going on. I cannot put my mechanical guys to work in that way. It's a very different ball game there. Getting them to work is the biggest challenge, then it's all part of the game. So, but we deliver at the end of the day. That's what it all counts there. So you must be able to appreciate the effort taken by each one of these faculty members. You should understand that. They are also your fellow engineers. They have built your careers. They may stay here, but they are the reasons why you might become great tomorrow. So this is something which Dr. Abdul Kalam acknowledged by honoring his own teachers years after he became a scientist and an acknowledged one at that. So I want you people to take up the three major things I told you: the GATE, the public sector, the examinations, and employability. All these things are going to give you a wonderful opportunity and career. And I perhaps think the civil engineers are the only ones who can see 40% profit in investment. I'm not wrong if I say so. No other business on earth gives you 40% back returns on investment. This is the only sector. If you are smart enough, you can always get 40%. Someone invests 100 rupees to build a building, you can 40 rupees is in your pocket right away. If you are smart, you must convince the other guy that you are doing good work, and also it should be sustainable. If you are able to do that, you can do it. You can check with some of your faculty members also. There's one I do not want to name. He's a real good investor in your department. I do not want to take his name now. He's a smart guy, one of the smartest guys in the campus as far as faculty is concerned. I don't take his name. So he's a two-wheeler savvy guy. That's the only clue I can give you. So these are the people you should understand. You do not understand what is the greatness around you. Dr. Lavanya is one, Dr. Veerappan is one. You do not see them as great people. You just see them as someone among us. Years after you left this campus, you would realize that some great fellow was shouting at the top of his voice to get us to do this. And you are just doing that years afterwards. So on this Engineers Day, I'm grateful to Madam and team for giving me an opportunity to give an unplanned address. I do not know what made sense about this address. I hope I did touch the right chord for you to think about. Happy Engineers Day. Vanakkam and thank you.
Thank you so much, sir. Now it's my pleasure moment to welcome my chief guest. Sir done BE Civil Engineering in 1990 at Vellore Institute of Technology and M.Tech Foundation Engineering in 2000 at National Institute of Technology and DCE Civil Engineering in 1986 Thandai Periyar E.V. Ramasamy Government Polytechnic College and PhD Structural Engineering in 2011 College of Engineering, Anna University, Chennai. Dr. J. Prabhakaran Sir is Chief Scientist at SERC Chennai. Sir received appreciation certificate from Director AMPRI for best completion of following projects. Constructed 16 apartments using innovative alternative building materials developed by AMPRI Bhopal using industrial waste. Also received Raman Research Fellowship from 2009 to 2010. CSIR Transformation and ICT Initiatives Bronze Icon Award of 2012 to 2013. Sir published 14 SCI journals and 33 plus non-SCI journals. Also published 4 book chapters. It's my pleasure to welcome our chief guest. Welcome you, sir. And now I request head of the mechanical department, sir, to deliver the memento and welcome our chief guest. Thank you, sir. Now I request head of the department, Dr. S. Lavanya Prabha ma'am, to deliver the bouquet and welcome our chief guest. Thank you, ma'am. I request chief guest to deliver the special address.
A very good afternoon. Happy Engineers Day. Maybe first of all, I thank Dr. Lavanya, HOD Civil Engineering Department, for inviting me to take part in reinstalling the chapters. I also thank all the professors and the student community for bringing me to have interaction today, as said by Dr. Lavanya. So I'll be just sharing what kind of research we have undertaken recently that will be delivering. So before going to that, I could see that your college is taking a lot of interest and nurturing you people at the student level to take part and also to take a lot of responsibilities during studies. So that makes you, it is going to make you to more confident in your future career. So just I was talking to your HOD, and you have been given a lot of opportunity to interact with the industries. When you go to the industries, you will find the demand. So when you interact with them, you will understand what kind of requirement they're really looking into that. So, see, we should all be proud. See, within the family, if somebody is coming and appreciating us, that is a matter. But from the outside, that is from mechanical department, so people are knowing that what important the civil engineering people we have. So he rightly pointed out, we are so comfortable in sitting with very cool air. So we are the civil engineer first to go into the this barren land, or maybe the land conditions are very worst. So we are taking a lot of responsibilities and making all other people to be very comfortable. So we should be proud being a civil engineer. So the great Mr. Srm Easwari is the father of our engineer. He has done excellent work, and to remember his birthday anniversary, and to honor the innovators. For that, this Engineers Day is now being celebrated every year. So that way, we all should be proud being a civil engineer, and we are having a lot of responsibility. When of course all other departments also is going to be take part, but still we have lot of responsibility to do all kind of works. So anyway, just I was discussing actually last 5 or maybe 7 years. So the intake from civil engineers are slowly it is coming down. I mean from almost all the colleges. But you don't worry. I feel that within near future, maybe 2 or 3 years, it will be there will be a lot of demands going to be there. So you can see now a lot of buildings are coming up, and really we should we don't have the right people. I mean particularly the maintenance. So buildings you can construct new building, but maintaining those buildings, bridges, or any other important structures is very difficult. So we have the people to take responsibility in learning how to solve the issue. See, now a lot of chemicals are coming. With the use of chemicals, people are not understanding thoroughly how to use the chemicals. Even if we use it, what kind of precaution, what kind of safety measures we one has to take. So those people, those things are not taken care. So because of that, even with the high tech material, if you are not using properly, so a lot of issues going to come. That kind of issue can only be addressed by civil engineer peoples. So you be all ready to take the responsibility. So really don't worry, your futures are very good. So on this day, I congratulate all of you. In near future, all you will shine. So with these small few words, I once again thank the organizers for calling me to be in this reinstalling the chapters. Thank you very much. So after that, I will be presenting my small research work we did at our institute. So with this, I thank you all. All the best. Thank you.
Thank you so much, sir. Now I call upon the President of Association of Civil Engineer P. Sivaramakrishnan to deliver the oath of thanks.
Good afternoon to all. I deem it a great honor and privilege to propose the vote of thanks on this memorable occasion. Let me start by giving glory to the Almighty God for making today's occasion a resounding success. First and foremost, I thank our chief guest, Dr. who, despite his busy schedule, has found time to grace this occasion, and I also express our heartfelt thanks to our HOD Mechanical Sir for his valuable contribution. We are grateful to our HOD Ma'am Dr. S. and their constant support, guidance, and encouragement. I extend my gratitude to all our faculties for their continued support in all our efforts. At last, I thank all the student coordinators and volunteers for making this event a resounding success. Thank you all.
Thank you, Shivaram. And we are very and I feel very pleasure to inform you as Yuvashri batch 2018 to 2022 got offered an L&T GATE graduate engineer training with a package of 6 LPA. Thank you. On behalf of Civil Engineers Day, Department of Civil presents the special lecture. So I request the chief guest to take over the session.
பேக்கில் 2 லைட் ஃப்ரண்ட்டில் பேக்கில் 2 லைட் கட் பண்ணி ரெக்கார்டிங் ரெக்கார்ட் பண்ணுறியா?
இல்லை யூடியூப் ஸ்ட்ரீம்
லைவ் ஸ்ட்ரீம். பேட்டரி இதெல்லாம் ஓடும் 9 வோல்ட் வச்சுக்கலாம்.
Hello. Yeah. I think all of you know Tamil? Yes, sir. Okay. Don't hesitate in asking Tamil also. Okay. I can answer it. So I want that whatever I am going to talk, you should understand. Okay. And Puriyalana, you can ask me in Tamil also. Tamil. Okay. Anyway. Hello. Hello. Hello.
ஸ்டூடெண்ட்ஸ் ஒரே இடத்துல உட்கார சொன்னாங்க. நடந்துட்டே இருக்காங்க. மேடம் இன்னொரு மைக் இருக்கான்னு கேளுங்க.
Okay. See, just now during inauguration, reintroduction of that chapter, Madam was talking about the sustainability. Okay. Sustainability is the big word. We cannot restrict with the one single area. In the sense, see, whatever the nature, if you are going to disturb, or you are minimizing the disturbance by means of making some alternative. So there itself sustainability is going to exist, going to come. So that way, as a civil engineer fraternity, so if you to understand easily, see now river sand is there. So that is generated by natural river flow. Okay, water is, it is coming from different hilly areas, then it is gathered, then along the way the rocks and all the things are there, it's rubbing each other, then particles are forming. So naturally, due to its gravity, so that layers are being formed. So this water level, whatever we are seeing in underground, that is always parallel to the earth surface. So when you remove the river sand, so what will happen? The water level also will go down. in those days, even I can, when I am in my village, I could see the water levels are just, within 10 feet or even 12 feet, that level. Those days, no electricity, there was no pumping, everything was done manually. So the water level was okay. So now the government is still banned because the things are, the water level, everything are going away. I mean, it's going very deep. So that is why they thought better we can go for, instead of going for river sand, we can go for yam sand. So again, what I'm saying is the sustainability aspect point of view they consider. But again, taking the yam sand, again we are going to disturb the mountains. So we are taking rock from the mountains. See, once the mountain is there only, again we will get good amount of rain. So we have to compromise one or another way. But what the maximum benefit which we are going to get? So that is the matter. So just to give some idea only, just I was explaining. So coming to this topic, here we are using lightweight. So when you go for the precast, we always think about the solid element. So it will have concrete and steel. So based on the IS requirement, if you consider any wall, it should not be less than 150 mm thick. So when we go for 150 mm thick, you see that consumption of concrete. So concrete, it requires river sand. So what we are going to we are replaced here is we have replaced almost 60% volume of this concrete or that panel by EPS, that is expanded polystyrene. That is called thermocol. Number in colloquial things we will tell color thermocol. So that means one is the advantage is we are saving the useful natural resource, that is sand, because we are going to consume only 30% of the raw materials. So remaining 60% of the material we are filling with the expanded polystyrene. So this EPS density is hardly 20 to 25 kg per meter cube. Whereas concrete, it has got 2500 kg per meter cube. So imagine how much we are reducing. Already I said 60% volume is reduced by replacing this EPS. So there you see that how much weight we are reducing in a panel. So one is lightweight, another is we are saving the natural resource. So that is the concept. So next please. So why we go for lightweight precast concrete? So now this precast concrete technology is not new. Even at my institute, SERC, in 1975, our seniors, they were worked on the area of precast technology. So they have constructed about 145 flats in Chennai itself, Nagar. But why it was not picked up? Because those days the availability of manpower is plenty. And very cheaper rate we can engage manpower to do the construction activities. But affordability of materials was the difficulties those days. But nowadays it is reverse. We are not able to get the trained masons or trained laborers or anybody. But we can able to buy the materials. So only the option is precast technology. So that is why you can say that almost most of the industries are come out with the precast technology nowadays. Particularly in northern part, in Delhi and all, a lot of precast construction industries have come up, and even now in our Tamil Nadu also there are 5-7 industries are mainly working and they are doing the construction activities using the precast technology. When you talk about a house, when you go with the masonry, so when you go with the masonry, what happens? You are using bricks or blocks or stone or etc. So we are one by one we are placing to have a monolithic things. We are applying the cement mortar and all. So on static or in vertical load, these all walls are good. When you think about lateral load, when the building exposed to seismic force, what will happen? It is weak in bonding. Whatever the brick stone we are using, it is strong, but the surface area what we are using and the mortar bonding strength, what we are using is it's weak. That is why whenever any seismic force comes, the walls, walls collapse. So that makes casualties. So to overcome that, if you go with the precast construction with the reinforcement, so this problem can be avoided. That is the one advantages. And when you go with the lightweight panel, it's added advantages. So it will not have, the impact will be very less. It will resist more forces when compared with the panel with the heavy weight. So just like to understand, easy way of understanding is, see, you are keeping one cartoon box on a table and you shake that table. What will happen? Nothing will happen. But if you keep any solid element over the table, you shake on the same amount of force, with the amount of force with you are done with the cartoon. You see the changes. It will have more of vibration and it will fall. So that kind of resistance will be more when you go with the lightweight panels. And another advantage is you can easily lift. Suppose you can engage a crane of 2-ton capacity. Whereas when you want to lift same amount of size panel, you need to have a 5-ton capacity of panel. So there are a lot of advantages are there. So anyway, how we have developed the panel and what are the different type of tests we have carried out. And we also constructed a G+1 building and a G+3 building in prototype. The first time in India, we did this lateral load study. So all those things I can going to explain one by one. Next, please. Next, this all three. So the advantages of precast technology is mainly the strength, speed, and safety. Of course, the cost is slightly, maybe we can say 10 to 15% will be the cost will be high. But if you calculate overall benefits, see, when you go with the traditional way of construction, it will take 10 months or so, for example. But when you go with this precast technology, within 2 months or 3 months, you can get your building and you can occupy and do your business. So that 7 months, whatever you are going to get, we can say rental value, or maybe you are starting much earlier your business, so you will be getting some kind of income. So if you calculate all those things, so precast technology is the one which can be still better. We can yield more income than the traditional way of no. And another thing is the quality, because being the product is being produced at the industry, so the quality is maintained. So traditional way of construction, so as I said, the people are not trained, so it's very difficult to get quality work. That is why you can see many buildings, even not even 10 years old, you will find a lot of dampness, particularly in the toilet regions. So they are not taking care how to fix it and what kind of precaution one has to see. So that those kind of problem is there. So next please. So these are some of the technology in SERC developed during 1975. I can just read it. Brick funicular cells, precast concrete funicular cells, both funicular cells using brick masonry. Here there is no reinforcement, only with the bricks. About 30 feet width of room is constructed only with the bricks. No reinforcement. You know, the bridges which are constructed in those days, 100 years before, it's mainly constructed using brick masonry. So the bricks and stones are, it is very good it will give very good compressive strength. So this tensile strength is taken care by, tensile strength and the other number use panro. Steel. But the steel has come only last 100 years or 150 years after that only, before only. But before that, there was no steel. And with the bricks and stone masonry itself, they are constructed bridges, house, or even temples and everything. And why they made this arch type? Because once you construct in arch type, the force which you are going to get completely off in compressive mode. So because of that only that arches is formed. The shapes convert the force into compressive force. So that is the thing. So that is where they were using funicular cell types. So it will just like have a arch kind of things. And they also developed precast joists and clay blocks. And of course, precast plate floor element. These are some of the technology developed in those days. Next, please. So now coming to the actual my presentation. So we have developed a precast lightweight wall and roof panel using expanded polystyrene. So let us see that what is EPS, how we are getting ready-made from the market, and how we have taken that material into developing the panel. Next, please. So this is the precast 3D wire mesh, EPS panel. It is available in the market readily. I think you might have seen this kind of panel. If anybody seen, no, you are not come across. So this panel is available readily. Okay. So we have taken this panel from the industry. And these are the property. These panels are available in different configuration. And this is the 100 mm thick. So if you want, we can use 50 mm or 80 mm. So depending upon the the span and the room size requirement, we can choose this EPS panel. This is available readily in the market. So whatever the configuration you wanted, so the factory people can give you this panel. So even this is 100 mm mesh opening, and if you want it, they will give 50 mm opening also. Okay, this all will help while designing. See, the more the closer, you will get more number of cracks, which will give us symptoms. Yes, this particular panel is under flexure. So it is slowly it is going to fail. That kind of indication will give. So when you go with the precast mesh, it will all of a sudden it is catastrophic failure. But here, when you go with the RCC, so you can able to see the bending. Next, please. So with that panel, what we did is, so this is the panel available readily in the market. So we have just it's a sandwich kind of things, See, the panel is kept inside, and all around we have poured the self-compacting concrete. So the self-compacting concrete, it has got, we can use either fly ash or GGBS. You know what is fly ash and GGBS? I think you might be knowing. This is an industrial byproduct. So in the thermal power plant, you will get fly ash, and from steel industry, you will get the slag, which is powdered, and you will get the GGBS, that is granulated blast furnace slag. So this waste product, you cannot say waste products, this is a byproduct. It helps. It has also got some bosonic properties. So here it is two properties. Two kind of role it plays. One is it is also got the bosonic properties, and the second thing is as a particle packing. Because when you go with the SSC, that is self-compacting concrete, so we need to have more of fine particles so that you can get flow. Because we have to pump it, and with SSC is for self-compacting concrete. The advantage is you record any external vibrations. When any congested rebar is there means, so you can use a self-compacting concrete. So here what happened, this is the skin is only 25 mm thick. See this skin, what are the top you are seeing, that is 25 mm thick, that is 1 inch, and all around the 25 mm only. So this is the EPS is 100 mm and both side 25 of the total thickness is hardly 150 mm thick only. Next please. This is a simple way of casting the panel. Record any sophisticated mold. See here you need only the channel. You can see it is the channel is made, a mold is made, and this self-compacting is poured in the inside the mold, and you are keeping the panel, and again you are pouring above the top layer. We are pouring with the self-compacting concrete. It is a simple way of casting. Initially, when we started, what we did was first we kept this panel and we have poured the concrete. After 7 days, we are turned from top to bottom. Again we did. So that takes a lot of time. So after that we experienced, and in a single stroke we got the panel. So next day you can lift the panel. Next please. So once the panel is ready, and we have put the panel under different loading conditions. So this panel is placed under 4-point bending to measure the flexural strength of that particular panel. So this panel is without having any additional reinforcement. Whatever you are getting the panel, that I said the 3D wire mesh. So with that we are used only concrete, and we measured the flexural strength. You will see what happened. Next please. You see this is the condition. So what happened? It is a catastrophic failure. As I said, in a pre-stressed concrete, all of a sudden it collapses, which is not allowed when you keep any member under flexural loading conditions. That is our slab or beam. So what we did is we introduced reinforcement so that you can have the ductile. It is all of a sudden, there is no deformation. Like a glass, you are applying the load, all of a sudden it will break. So we should know that when this beam is going to fail, then only people can escape. If something goes wrong, we can escape. There won't be any casualty. But all of a sudden collapse means then some issue is going to be there. So that is what we have introduced edge beam. Both the side, we have introduced reinforcement. And we also provided bottom level, we have provided 8 mm rod of 5 numbers. So just we want to know that what is that, how that panel capacity can be improved. So here you can see the mesh with 100 mm opening and mesh with 50 mm opening, without edge beam, with edge beam, and edge beam plus bottom reinforcement. Here you can see that. See, the design requirement is very less only, but the panels could be able to get high amount of flexural value. But only the issue, as I said, is catastrophic failure. To avoid that one, we have introduced edge reinforcement. Otherwise, the panel is okay. We can use it for 10 feet span. When you go for higher span, suppose more than 12 feet, then we have to think of introducing reinforcement. Then for that capacity, we have to design. Next, please. So this is the different in that is the numerical form we have presented. It is the in curve form it is presented. The same. Next, please. So if you calculate that, what is that the panel? The panel should have should carry the load. If you see, if you calculate the load point of view, is only 19.3 kilonewton is sufficient. If the panel carries 19.3, that is more than sufficient when it is peak load. In service load, in general, in service load, 12.88 kilonewton is more than sufficient. Whereas this panel is the ultimate load it is carried is 46.8, which is more than sufficient. So that is what you can see here. For 3 meter span, this panel is more than sufficient to take care of the load which you are expecting. Next. So one can see that, think. So you are using only 1 inch thick concrete. What will happen if somebody in a safety aspect point of view or security aspect point of view, if somebody come and hit the panel, whether they can easily go inside the house, whether it can punch or it can make a hole. For that, we did this, we have put panel under punching load. See, even under we can see this has taken about 32.3 kilonewton, that is about 3 ton load, even it was not failed. Because the mat is there. It is acting as a ferrocement behavior. So you see, if had it been punched, within no time it would have taken the hole and penetrated other side. But you see that load is transferred and it formed. You can see here the crack pattern indicates that shear connectors are effective because it is also connected. This bottom layer as well as top layer is connected through vertical bars. That is the shear connectors. That is more effective. Cracks are due to tensile stress and hence it is clear that top width is not subjected to only compressive. And these cracks are due to local punching. Further cracks may not form at large diameter. See, here you can see the ferrocement, the load will be, the truss contour, you can see that it is just going from center to the edge. That shows that it is well resist towards the punching shear. So there won't be any issue with regard to impact load or something like that. Next. And we also placed the panel under axial. So that panels we are designed for the slab, and this panel we are designed for the wall. So here also what we did is, as such we poured the concrete, then we placed under axial load. So that panel was taken only 400 kilonewton initially. Why? Because at the supporting region there was local crushing. So thereby it was not undertaking, the panel was not fully undertaking the load. Then what it did was, we have introduced edge beam, wherever the support is there, no? So there we have introduced the edge beam. Then we placed under the axial load. So it could take 1200 kilonewton. Because while applying the load at the top, the composite action is taking place. But if the beam is not there, means the local crushing is taking place, so it fails. So that is what, to have the full capacity of the panel, we want to utilize the full capacity of the panel, we recommend to have edge beam, particularly when the panels placed as a wall. So that is the information we got when we do this test. Next, please. Okay. Again, we also did how the panel is behaving when you do the shear lateral load. So for that also we did. And what we did is, when you remove that insulation, that is the EPS, only with the wire mesh, what is the shear? Or with the EPS, what is the shear? Again, when you increase the thickness of the panel, what is that shear value, shear capacity. So naturally, one can, civil, we can understand that particularly in shear, when the thickness comes down, the capacity will increase. When the thickness increase, it will fail. Not fail, I am telling you, it will take less amount of load. But to quantify it, we have studied these studies. And here we can see the panel with the insulation layer, that is the presence of EPS, it resists more load. When you remove, it will come down. So similarly, when you increase, if you see that 150 mm thick, it will have less when compared with the 100 mm thick panel. So that is the kind of information we got from this study. All this information is very much useful when you go for designing the structure, building. So how we are carried out and what is the value, that is what I am sharing with you. Next, please. So in precast construction, joint is very much important. That why I am telling is, see, the precast we are thinking to make the building into very faster way. If you make the joints in more complicated way, then there itself will consume more amount of time. So we have to come out the easy way of the connecting the panels. So within shorter time, you should connect the panels. At the same time, you should take the load which we are expecting, both lateral as well as in axial. There won't be any issue. Mainly the lateral load is only governing whenever any wind force or seismic force and all the things will we are expected. So here, what we made is this. For example, this is the foundation. I think the left side corner, and what we are designed was the panel width is 1.2 meter. So every 1.2 meter there will be a double bars comings from the foundation. So the double bars we did some analytical studies. So the double bars with what diameter? Suppose we are going for 10 story or we are going for a 3 story or a single story. So we have to design what could be the diameter of the rebars and how many numbers. So that needs to be studied. But in our case, for G+3, up to G+3, we did modeling. For that, we need to have only 10 mm for G+2 and G+1. G+3, 12 mm is more than sufficient. So that is what we have arrived. And so this is the panel, whatever I said was 1.2 meter by 1.3 meter, 1.2 meter in width, 3 meter in height. If you want to go for large panel, so for example, this is a one room size. In the right hand side, you can see, if you want to make one room size, big size, large panel means we need to integrate this panel, that is 1.2 meter, 1.2 meter, and another 1.2 meter, like that. So to integrate, we need to introduce reinforcement in between, and that reinforcement with the panel, we have to give lateral reinforcement also. So this is the way we have fabricated, and you can see that that whatever the bar extended, that is the place where you are going to connect one panel with the other panel. So that, see, like this, if you see that this left side corner, see how the bottom floor panel, bottom floor wall panel, it is with the double bars, it is there, and over that we are also have a ring beam kind of things. So that will have holes. So this rebar will come into that, and the top rebar also will come. There will be an opening here. You can have a overlap kind of things. So the overlap, and further in addition, we are going to weld it so that it will have maybe an additional strength. So this is the concept design we have arrived. In reality, whether it is going to take the load which we are expected from the lateral. So that we did a study with the next slide you can see. Next. So here you can see that. So as I said, different type of joints we have studied. What is simply overlapping. Another is overlapping with the along with the welding. And another one is we have also made some kind of bending at the tip. So all these three we have studied. And here, for example, this is the foundation. Here, this is the panel we are connected. So from foundation to rod will come. From this panel to rod will come. That is overlap. And that particular place, it is inside the concrete will be there. And this place. So this panel we have you can say that we applied the load at that top. Then we have measured the drift, how much displacement is there, and how much load it is carrying. See, when you construct a building, the seismic force, it will have the lateral load only. So that is where we are applying at the top, and we are finding it where the failure is going to come, and what is the interstory drift. So that is what information gives from this test. Next, please. Here, what we can observe here is the joints with the overlapping and welding yielded good amount of load. So the year we are adopted in our reality studies, I mean G+1 and G+3, we used this joints techniques. Next, please. Next. Okay. Is previous? Okay. Next level. Okay. See, now what happened? We did. We have studied joints. We have studied the slab panel. We studied the wall panel. So combinedly, how it is going to begin. So that is what here we have studied. Here, what we did is this. For example, this is the foundation. There we have fixed the wall panel at both sides. And as I said, ring beam just above the top of the wall panel. We have somehow it's not working. Top of the wall panel we have fixed. Then above that we have placed roof. I mean wall. So here the idea is in the here is see we are confident about the wall. We are confident about the joints. If the wall alone, the roof alone want to fail, in such case, there should not be any displacement on the wall. இப்போ எனக்கு வந்து இந்த வாலும் பீமும் வந்து பொசிஷன்ல இருக்கணும் அப்படின்னாக்கா ரூப் வந்து ஃபெயில் ஆகணும். So that is my objective here. See, suppose my room is there. I know what is the full capacity of the roof. If I want to assess my wall, or my wall should be strong, suppose. In that condition, what I have to do? I see that my roof should collapse. So that is what we did here. So for roof, we required only hardly we saw 18 kilometers only we required. But ultimate load it has gone up to 46. That is the maximum capacity of the panel. So we saw that the roof panel alone should fail. Even we gone up to 46, we measured the lateral drift and we measured is there any failure on the joints and all. So nothing happened. So that is what we have studied here. Next, please. So you see here, the roof alone got cracks. That shows that whatever the wall element with the joints and the beam, it is very strong. So that is the kind of information we can get from this setup. Next. Video next. முன்னாடி போங்க. இல்ல முன்னாடி இல்ல நெக்ஸ்ட் இல்ல முன்னாடி போங்க. அந்த ரைட் சைடுல கிளிக் அந்த போட்டோ மேல கிளிக் பண்ணுங்க. Directly you can click on that. இல்லை கர்ஷரில் அப்படி கிளிக் பண்ணுங்க. So this is the setup we have in our institute, and you can see a lot of wires are going. You see, so we are measuring strain gauges, and a lot of LVDT also placed. So in the side wall, at the mid level, at top level, even at the vertical level, in all the direction we have instrumented with the LVDT, linear displacement tools, and also strain gauge. So all these things are within the acceptable limit or not, that we have we observe. So from these studies, we understand that the joints which we have designed is perfect. So that is what we could. Next one. See, now we have studied panel, wall, and combined these things. Now we want to go for larger size. So whatever we studied so far is the size which are available in the market. Now we want to go for larger size, that is 3 meter by 3 meter. Instead of, previously we did the 3 meter by 1.2 meter only. Now we have gone with the 3 meter by 3 meter. Next, please. So, as I said, to integrate the, to increase the size, we introduce the, reinforcement. There are 3 panels are there. So in between we have run the reinforcement, that is the 2 numbers of 10 mm with the 150 mm center to center stirrups. So the mesh we have removed partially. The EPS partially remove panni, 2 panel we are kept like this. So below that one the reinforcement is running. So by the way we are getting 3 meter by 3 meter. Even we can go add 1 more panel also. So for that you have to design. So what will be the reinforcement dia that we have to design. So here we have cast this slab, and during that one we have instrumented with the strain gauges, so that the information shows that what are the location where the strain gauges are fixed. And can you play that lifting video? See, particularly when you cast the panel, we have to lift it in second. As early as possible. Otherwise, you need to have more area to cast the panel. So we have to see that at what speed we can remove the panel from the mold, so that with a less amount of area you can cast more number of panels. So how to lift the panel? So that is the most important. So the next day, if you see this concrete is M40 grade we use. Next day, how much you will get? Only 9 MPa. Within 24 hours, you will get 9 MPa only. So it is designed for 40 MPa, but first day 24 hours strength you will get 9 MPa. Whether that 9 MPa is more sufficient to lift the panel. So on the studies we did with the modeling. So the modeling gave confidence. Yes, you can lift it, but how to lift it? You have to lift it in actual mode only. So that is what that video will says. And you can go with the folder lifting the video. Other yes. So this is lifting on the device. So this is the way you have to lift it. This was just immediate after 24 hours. So it has got only gained 9 MPa only. So if you wherever you lift on the local on the position it will tear. So you have to lift it in vertical. So the precast particular, but in the here what happened? It is both the way mesh is there. Top also mat is there. Bottom also mat is there. So here there won't be any question whether you have to lift from top to bottom or bottom to top. Because in slab what happened, we are always provide the tensile reinforcement at the bottom. So you have to lift it the same position only. If you lift it reverse, it will collapse. But in this case, it is the the reinforcement is both top and bottom layer is same. So that way there won't be any issue. Even if you make it up, top to bottom, you can lift it. Nothing will happen. Only the question is how we are going to do now. That is the issue. Otherwise, once it is matured, suppose 28 days is over, so you can lift it any direction. Nothing will happen. Next, please. So after curing, we have placed this panel under 12-point bending. So we want to measure what is the capacity of the panel. So this 3 meter by 3 meter panel, it carries 19 ton load. That is a 190 kilonewton load it has taken. Whereas in the ordinary panel, you don't require that much capacity. But this panel is taken, and we also studied what is the behavior, whether it is a one-way slab behavior or two-way slab behavior. That also we did. Next, please. So you can see that the panel carried about 19 ton load. Next, please. I'm not going to the detail, just I'm giving some idea. So you see the behavior of the panel. It acts as a two-way slab. This is good. Next, please. So this is the kind of the deformation and the load versus deflection curve we have plotted. And in a particular slab, we required only hardly 67 kilonewton load only. If you design for 3 meter by 3 meter span, the service load and the actual load your requirement is the service load is 45 kilonewtons is more than sufficient. But this panel is taken 195 kilonewtons, so which is more than sufficient. What it shows that this panel can be very well used, provided you ensure about the connection between the two panels. Next, please. So now we did all the studies panel wise as well as with the combined effect, as well as we did larger size also we have studied. Now we want to go for the actual constructing a building, how it performs. Panel wise we did. Now we are going for the as a system, how it is behaves. For that, you can see that we are, as I was telling, we are integrating the panel like this. So that two panel will get, so the in between the reinforcement is running, and to have the bond connection, so we are giving the lateral reinforcement like this. So now the panels are ready, and for according to that size, we have prepared the mold again with the simple mold. It is with the G channel, and you can see that now the concrete is poured. Next, please. So the panel is ready. So before going to the again, see whenever in research what we do, we optimize the the material requirement or the sections and everything. Otherwise, if you do all experimental studies, we will be wasting our time and wasting the money and wasting a lot of raw materials. Before going to that, we do the analysis and the optimized results. We will go for casting. So that is what we do. And here we are, before going to the actual setup, so we should know that how much load we are expecting. So accordingly, we will have to choose the actuator and whatever that the tools, equipments required to conduct the test. For that purpose only, we did all these analytical studies. So from that analytical studies, now this building is taken about 35 ton lateral load. Next, please. So for to have that studies, we cast the foundation with the double bars. Here you can see that wherever the panel, so these are the two rods are coming from this roof, and this we are taken about 3 meter by 3 meter size room, and with the openings, because in the reality we have window opening, door opening. So because the openings are the most vulnerables, where you can get the cracks, where you can get the failure. So in the same things we have considered, and we have constructed the large wall panel, and we are here. You can see we are assembled. In the assembling also, in particular in precast, which panel has to be placed first? That is most important. So pre-engineering is much more important when you go for the precast technology. So if you wrongly place other one panel here, means you cannot fix other panel. So you should have that which panel, because the size and everything are different, and one panel will come in contact with the other panel. So there one has to more careful about the sequence of erecting the panels. Again, how to keep the panel in a position, that also most important. So here you can see the panels are just supported with the prop systems, and how these props are fixed with the panel, that also most important, because if you are spending more time on this, then again whatever the objective you are thinking, it will become worst. So that is why you have to choose all the system in simplified manner, so that within no time you can remove it and you can go for erecting other panels. Next. So, and wherever the joints are there, and we have instrumented with the strain gauge to understand how much strains are coming while buildings under lateral load. Next. So now see here, you can see that we also applied the live load and on the floor, both the top as well as the middle floor, we applied a live load. Here you can see here, at the top of the things you can see that live loads are applied. So video can able to play here. Okay, anyway, see here in the, you can see that curve, the numerical studies and almost the experiment is almost in 5 to 10% variation is going to be, which is expected. So it carried up to 35 kilonewton ton, 350 kilonewton, and we have gone up to the failure. So the failure where it mainly it's happened only on the direction of the, suppose we are applying, I am pushing this side means naturally this whatever the rebars from my side, it will have, all will have under tension. So we start failing at this end only. In the meantime, we also observe some cracks inside that building. So since we have gone with the ultimate load, we were observing. Otherwise, whatever the, as per the seismic force, if you restrict with that load means, then nothing is happening. No cracks, nothing. So we want to know the full capacity of the building. So that is why we went up to 35 ton. Otherwise, you need to have only 15 ton. Load is more than sufficient when the building is put up under zone 5. So if we calculate only that much load is, it can building should take care. But as I said, we want to see that what is that full capacity building can stand. For that we did. Next please. So these are the observed, cracks pattern we have seen. See, completely it is a horizontal crack, because we are pushing this way means naturally it is expected the cracks are in horizontal direction only. Next please. So this is the performance point based on IS 893 seismic aspect point of view. Whether these buildings is what are the capacity is carried, it is under demand zone we have calculated. It is well within the safe limit. Next. This video we can play. Actually, this building we have shake table in our institute. What you are getting time?
No. Full scale model, no? Just, I wanted to tell the parents. It's a full scale model.
Yeah.
They may not be understanding.
Prototype actual வீடு நம்ம ஒரு room size நம்ம கட்டுறோம் இல்லையா, rooms minimum size 3 meter 10 feet by 10 feet இல்லையா. Model you can bring down the scale. இப்போ 3 meter க்கு என்ன பண்ணுவோம், 30 centimeter எடுத்துக்குவோம், அதுதான் model. But whatever studies, whatever the presentation I made is the real size. Okay,
you can see the building is constructed and reality is
இது நம்ம ஒரு shake table இருக்கு எங்க இன்ஸ்டிடியூட்ல shake table. It has got 40 ton capacity of size 3 meter by 3 meter, 10 feet by 10 feet irukku. So that can generate up to, depend upon the building ku naanga 1 G varaikum polam. So number zone 5 ku 0.36 G is sufficient. For zone 1, zone 2, zone 3, zone 4 nu solraliya earthquake.
+1 it is constructed, after that they are testing. You can see the facility available. It is, this lab is very nearby to you. We were going for final year students, ME students, you are all going for your thesis writing and project. Any type of testing is possible. how to make use of that, understand the facilities.
Play பண்ண முடியல ஆகலையா அதில் வெளியே போய் பண்ணுங்க so that you can see that that building completely shaking. இப்போ நம்ம அந்த ஷேக் டேபிள் வச்சு ஒரு பிரிக் மேசன்ரி
lateral loadல எப்படி ஷேக் ஆகுதோ அதே மாதிரியே காம்பேர் சார். இது
எர்த்குவேக்ன்றது வந்து 3 டைரக்ஷன்ல வரும். ஓகே, இட்ஸ் a dynamic force. ஓகே, புஷ் ஓவர்ன்றது only lateral ஹரிசாண்டல் வரும். இது வந்து எங்க கிட்ட இருக்கிற இந்த ஷேக் டேபிள் வந்து இட் கேன் ரொட்டேட் 360 angles. இது இல்ல அது வந்து சைஸ்மிக்னே இருக்கு பாருங்க. சாரி, சைஸ்மிக்னு இருக்கு பாருங்க. G. No. Yeah, that is all. It is not supporting. Get it. Get it. அது இன்ட்ரெஸ்டிங்கா இருக்கு பாக்குறது. அதான் ஜஸ்ட் டைம் அதுல அந்த ப்ளே பண்ண முடியுதா பாருங்க. வீல்ஸ்ல வந்து இல்ல. You see, this building is completely erected on the shake table. You can see that window opening, door opening. You can see that high speed camera, non-contact laser to measure the interstory drift. இங்க பார்க்கலாம். இந்த ஷேக் டேபிள்ல வந்து உங்களுக்கு தெரியும் ஒன்லி இப்படிதான் இருக்கு. It is rotating. So this building we have studied up to 0.5 G, which is not necessary. But even 0.5 G le nothing happened. இதே நம்ம பிரிக் ஸ்ட்ரக்சர், ஸ்டோன் மெசனரி அந்த மாதிரி யூஸ் பண்ணிருந்தோம்னா இது வந்து 0.16 G லே வந்து கொலாப்ஸ் ஆயிடும். So that is the beauty. Because the panel is completely mesh 3D wire la வந்து 3D direction la mesh இருக்கு. Very closely placed. That is the advantage. So that is what one should understand. Next. So G+ one early study பண்ணோம். Again, government of India, they wanted that they were having a scheme to construct house for the houseless people, for the economically weaker sections. So அவங்களுக்கு வந்து என்னன்னா ஒரு பெட்ரூம், ஒரு ஹால், கிச்சன், லெட் பாத்ரூம். So அந்த சைஸுக்கு we have gone next. Okay, for G+3 again we did the analytical modeling and we have expected how much load it is going to take. So accordingly we have made the arrangements for all the necessary equipments. Next please. இதுல வந்து இப்போ இதுல precastல வந்து particularly how to transport the panels, that is much more important. Stacking also much more important. As I said just before, the flexural member particularly, you should know that how to lift it when you keep or when you place the steel in the bottom, at the bottom. But in our case there's no problem because the reinforcement is both top as well as bottom. It is uniform, so that thereby lifting is not the issue. One advantage is here, as I said, the weight of the panel is just 1/3 the traditional precast panel. So in a truck, if you are carrying about, suppose for example, some 4 panel of traditional means, here you can carry 8 or even 10 panel. In single shift, you can transport many number of panels. That is another advantage. So in reality, to understand how we can stack the panel in real truck, and whether it is while transporting any breakage is taking place or not. So all those studies we did. So that is what this shows. So this is the kind of lifting the panel. How by using our normal crane you can lift it. Next please. So as I was telling, we did the G+3 again the real size prototype, actual size. So for that we have created one test pad. So in the building after testing you want to remove it. Suppose if you do it in the site itself, what happened? We'll be wasting that particular place. because we want to do many number of such building. For that, a removable platform is fabricated in our testing place center at TTRS, that is Tower Testing Research Station, just opposite our airport. We have one big testing facility exclusively for the high transmission line towers. Full scale, up to 100-meter height, you can test. And that is the kind of facility we have. So, over that, we have erected the panel. And again, as I said, the sequence of panel erection is much more important. Okay, next, please. So, this complete erection we did within 4 days. Even because we don't have experience, we don't have any trained person also. With the locally available person only, we have made this thing. Had it been experienced, you could have done it in a day. So that is the kind of speed one can do. And as I said, you see, the opening is very, very less. You see, only the pockets, 150 mm by 150 mm size only, you have to pack it at the side. Almost here 90% of the concrete work is done in the casting itself. Only the connecting the the one rod to rod like this, that particular pockets only we need to fill it with the, even we can go with the geopolymer concrete also. Curing also not required. So you will get within 24 hours the strength what you are looking for. So that is also possible. So the idea is we want to minimize the maximum amount of in situ work. So here you can see that. Next, please. So now the building is completely ready, and here we are at different floor level. We have instrumented with the LVDT to measure the displacement when you pull. You can see that at the top of it there is 2 wire of both the sides are going. That is pulled. So here it says that the different load and what is the deformation that we have measured. And again, this building is taken about 60 ton of load, which is sufficient. So that is the things we did in reality. Next, please. So again, of course, we also compared with the IS 8913, and the performance curve was drawn, which shows that up to zone 4 it is very safe, and zone 3 we need to strengthen the joints. So that is the information it gives actually. Next. So with this technology, we have constructed some demo buildings within our campus, and also we have constructed one school building at CLRI. And this technology has been transferred to 5 industries. And one of the industry, they have built about 500 houses for Andhra Pradesh government. Here you can see the right side corner. You can see that this building is with our technology. Next. Yeah, this is the information I said already. Next. Oh, thank you. Thank you. உங்களுக்கு எதாவது டவுட் இருந்தா கேளுங்க, ஒன்றும் ப்ராப்ளம் இல்லை. ஸோ உங்கள் லாங்குவேஜில் கேளுங்க. ஸோ நத்திங் டு வரி. எலக்ட்ரிக்கல் பிளம்பிங் ஒர்க் வந்து அகைன் இட்ஸ் அ ப்ரீ என்ஜினியரிங் தான். இப்போ நீங்கள் ஈவன் ட்ரெடிஷ்னல் ப்ரீ காஸ்ட்டுக்கு என்ன பண்ணுவாங்கன்னா, they will draw that service line. They will draw the service line. Okay. Accordingly, while casting itself, they will insert the pipe, both plumbing as well as electrical this thing. So precast la enna pandromo adhe da inge. So this we have just for study purpose only we did. When you go with the reality, even on the 500 houses they built it. No, they did with the inserting the conduit pipes and then they made it. Actually, that particular house, what they did was they installed only the panel. The EPS panel in the site of the gunneting panitanga. That is also another kind of making the things. But நீங்க செல்ஃப் காம்பேக்டிங் கான்கிரீட்ல போனீங்கன்னா it will have more durable. இப்போ நீங்க கிரானைட்டிங் மாதிரி போனீங்கன்னா என்ன ஆகுன்னா it will not have any compaction. இப்போ பிளாஸ்டரிங்லாம் பாத்தீங்கன்னா இப்போ இருக்கிற ஜஸ்ட் ஃபார் இன்ஃபர்மேஷன் ஐ வில் டெல் யூ, நேச்சுரலா என்ன பண்ணா ஒரு ஹாலை பிளாஸ்டர் பண்ணோம்னாக்கா அந்த மாட்டரை வந்து நம்ம வால்ல அடிச்சுட்டு we have to லெவல் பண்ணிட்டு மேஸ்திரி என்ன பண்ணுவாங்கன்னா அதை நல்லா அழுத்தி தேய்ப்பாங்க. இந்த அழுத்தி தேய்க்கும் போது என்ன ஆகுனா it will have more compact. அப்போ அந்த உள்ள இருக்கிற cement slurry it will come out. So that ensure that you are making the mortar into compact way. அந்த மாதிரி பண்ணும்போது என்ன ஆகுனா இப்போ மழை வந்தனா என்ன ஆகும், தண்ணி வந்து உறிஞ்சுமா? உரியாது. ஏன்னா it is completely packed. So when water will go inside, if any porosity is there, and the voids இருந்தா தான் வந்து தண்ணி உள்ள போகும். So once water goes inside, naturally when it reaches to the rod, it start reacting. So ராடுக்கு வந்து ஸ்டீல் வந்து கரோட் ஆகிறதுக்கு you need only moisture and oxygen, presence of this thing. But the chloride and the carbon dioxide எல்லாம் இருந்ததுன்னா it will aggravate, accelerate, and the speed increase பண்ணும் அது. Otherwise நம்ம வாட்டரும் வந்து ஆக்சிஜன் இருந்தாவே ஸ்டார்ட் கரோடிங். ஸோ அதனால அப்புறம் இப்ப இருக்கிற சிஸ்டம் எப்படி இருக்காங்கன்னா, இதே வால்ல மேஸ்திரி வந்து என்ன பண்ணாரு, சப்ளைங் த மோட்டர் வித் லெவல் ஸ்டிக், யூ வில் டூ லெவல் இட் அண்ட் யூ வில் புட் தி சிமெண்ட் ஓவர் தட். அந்த ஒரு பாலிஷ் டிராவல் மாதிரி ஒன்று இருக்கும், அதை வச்சுட்டு யூ வில் மேக் இட், யூ வில் நாட் அப்ளை த லோட் அட் ஆல். அப்போ என்ன ஆகும், இட் வில் பி ஜஸ்ட் லைக் எ ஸ்பாஞ்ச் இல்லையா? இப்படி அழுத்தி தேய்ச்சாதான் வந்து காம்பேக்ட் ஆகும், உள்ள இருக்கிற வாய்ஸ் எல்லாம் ரிமூவ் ஆகும், ஃபுல் திஸ் திங் ஹோமோஜினிட்டி மாதிரி இருக்கும், இன்டெகிரிட்டி நல்லா இருக்கும். இப்படி பண்ணும்போது என்ன ஆகுனா ஃபுல்லா வந்து போரஸ் பயங்கரமா இருக்கும். அப்போ என்ன ஆகும், மழை பெஞ்சா தண்ணி உறிஞ்சு உள்ள வச்சு. ஸோ தட் இஸ் வேர் யூ கேன் சீ த ரீசன்ட் பில்டிங்ஸ், ஐ மீன் மேபி 10 years or 15 years இது கண்ணதெல்லாம் பார்த்தீங்கன்னா நிறைய டேம்ப்னஸ் நிறைய இருக்கும். அதான் நம்மளுக்கு பார்க்கறதுக்கு வந்து இட் வில் பி லுக் வெரி சிம்பிள் திங், பட் தட் மேக்ஸ் பில்டிங் இன்டு வெரி டேஞ்சரஸ். ஸோ அதுதான் ஒரு சின்ன சின்ன விஷயத்துக்கு நம்ம வந்து ரொம்ப ஃப்ரீ ஆகிட்டோம்னாக்கா it will affect. So that is something, I mean, sorry, I'm going to other thing, but anyway, it's a good information. So if anybody wants to ask. Okay. இந்த மாசம் வந்து 26th வந்து every year 26th September CSIR, I mean not only in SERC, all over India we have 38th institute comes under Council of Scientific and Industrial Research. இது வந்து டிபார்ட்மெண்ட் ஆஃப் சயின்ஸ் அண்ட் டெக்னாலஜில இட்ஸ் ஒன் ஆர்கனைசேஷன். அதுக்கு கீழே வந்து 38 இன்ஸ்டியூட் இருக்கு. இந்த 38 இன்ஸ்டியூட்டும் வந்து டிஃப்ரெண்ட் ஃபீல்ட் ஆஃப் எக்ஸ்பர்டைஸ்ல இருக்கும். ஃபார் எக்ஸாம்பிள் நான் வந்து ஸ்ட்ரக்சரல் இன்ஜினியரிங் ரிசர்ச் சென்டர் தரமணி அங்கே வந்திருக்கேன். அதே மாதிரி நமக்கு இன்னொரு இன்ஸ்டியூட்டும் சென்னையில இருக்கு, CLR சென்ட்ரல் லெதர் ரிசர்ச் இன்ஸ்டியூட். அவங்க வந்து லெதர் ரிலேட்டடா வந்து தே வில் பி ஒர்க்கிங். ஸோ இந்த எல்லா 38 லேபும் வந்து 26th September அன்னைக்கு வந்து பப்ளிக் வந்து பார்க்கறதுக்காக அலோவ் பண்றோம். ஸோ அது வந்து ஃப்ரீ, எனிபடி கேன் கம் அண்ட் விசிட் ஃப்ரம் மார்னிங் வந்து 9 to ஈவினிங் ஒரு 2 o'clock வரைக்கும் வந்து நீங்க வந்து விசிட் பண்ணி பார்க்கலாம். ஸோ மற்ற டைம்ல வரணும்னா லாட் ஆஃப் ரெஸ்ட்ரிக்ஷன்ஸ் ஆர் தேர். ஸோ யூ கேன் யூஸ் தி ஆப்பர்ச்சுனிட்டி. ஸோ யூ கேன் கம் அண்ட் சி வாட் எவர். இப்போ இதை காமிச்சது நீங்க அங்கே டெமோ பில்டிங் இருக்கு, அந்த டெஸ்ட் ஃபெசிலிட்டிஸ் இதெல்லாம் பார்க்கலாம். யூ வில் கெட் எ ஃபீல் இல்லையா? இப்போ நீங்க மார்னிங் இந்த சாப்டர் வந்து உங்களுக்கு வந்து ரீஇன்ஸ்டால் பண்ணதே வந்து உங்களுக்கு ஒரு கான்ஃபிடென்ட்டை கிரியேட் பண்றதுக்கு தான். ஸோ இஃப் யூ கோ அண்ட் மீட் சோ மெனி பீப்புள் மீன்ஸ் யூ வில் ஹேவ் மோர் கான்ஃபிடென்ட் அண்ட் யூ வில் கெட் கான்டாக்ட் அண்ட் யூ வில் ஹேவ் ஃபியூச்சர். ஸோ அதுதான் பட் நீங்க வந்து நாலேஜை வந்து கெயின் பண்ணணும்னா வந்து இந்த மாதிரி ஆப்பர்ச்சுனிட்டிக்கு வந்து பாருங்க. யூ ஆர் மோஸ்ட் வெல்கம் ஆன் தட் டே. தேங்க்யூ. வேற என்ன கொஸ்டின் இருக்கா இந்த பிரசன்டேஷனை பத்தி?
இந்த டாப்ல நம்ம மாட்டர் வந்து 50 mm க்கு தான் அப்ளை பண்றோம் இல்லைங்க சார்? 50 mm
எங்க
EPS-க்கு மேல சார், EPS பேனல்
இது வந்து கான்கிரீட் பண்றோம். ஓகே.
இதுக்கு வந்து செல்ஃப் காம்பாக்டிங் ரிக்வயர்டா சார்? only for 50 mm.
இல்ல செல்ஃப் காம்பாக்டிங்னா ஒரு லெவல் பண்ண இல்லனா வந்து அந்த ஒரு சி இப்போ 0 ஸ்லாம்ப் இருக்குதுன்னா ப்ளீஸ் 0 ஸ்லாம்ப் இருக்குன்னா அது லெவல் பண்றதுக்கு வந்து யூ நீட் எக்ஸ்ட்ரா this thing, I mean energy. Again it will take lot of time. Just if you pour into the mold, it will in the self way also it will go and occupy. Slightly you need some mason has to pull the material. So another self competing concrete இது பண்றது.
ரூர்க்கில ஒரு பில்டிங் பண்ணிருந்தீங்கல சார்?
எங்க?
ரூர்க்கில
என்ன பில்டிங்?
CSIRல இருந்து ரூர்க்கில இந்த EPS பேனல்ஸ் யூஸ் பண்ணி ஒரு பில்டிங்.
No, ரூர்க்கில வந்து நீங்க அந்த 14 story within 24 hours that you are telling?
G+3
G+3 இங்க தான் பண்ணது.
EPS பேனல் பிளஸ் ரூர்க்கி கவர்மெண்ட்க்கு பண்ணி கொடுத்தோம். ரிப்போர்ட் அவைலபிள்.
Okay, அது மேபி
அதில் வந்து அவங்க இதுதான் ஷார்ட் கிரிட்டிங் தான் யூஸ் பண்ணியிருந்தாங்க சார்.
இல்ல அதுதான் இப்ப நான் சொன்னேன். இந்த woodwood இந்த cycloneக்கு 500 houses they built, no, they did with the short critic, gunneting kind of things. So the panel is erected at the site, then they will with the mortar they are gonna did the short critic. But this technology, another technology is concrete, completely concrete. This is it will have more durable and more strong also. But in the case la vandu koncha durability aspect pandapli some issue will be there. Yeah, it will be there.
Any other queries? See, the final year students, you can apply for projects also. If you want to.
Yeah, already website la potirukku. Website la vandu the terms and conditions irukku, the minimum qualifications etc. everything is mentioned. So people interested and you can apply, and the topic also given. So you can choose the topic on your own interest. So whatever the topic you are interested, so you can choose. So நீங்க இமிடியேட்டா பண்ணீங்கன்னா இப்போ உங்களுக்கு ஆப்பர்ச்சுனிட்டி கிடைக்கும். இப்போ வேற காலேஜ்ல இருந்து வேற யாரனா சூஸ் பண்ணிட்டாங்கன்னா அவங்களுக்கு போய்டும். So அதனால நீங்க வந்து முந்திங்க, அதுதான் சொல்ல முடியும்.
There are not only on structures, you can do projects in environmental also.
Yeah. We have NEERI inside. Actually, we have another 5 zonal units. Like நான் சொல்லியிருந்தேன் இல்லையா, இப்போ நீரி இருக்கு. நீரி வந்து மெயின் இடம் வந்து நாக்பூர், அவங்களுடைய ஜோனல் யூனிட்டிங் இருக்கு. சிஎஸ்ஐஓ அது இருக்கு, சிரி இருக்கு, சிக்ரி சென்ட்ரல் எலக்ட்ரோ கெமிக்கல் ரிசர்ச் இன்ஸ்டியூட் அது இருக்கு, நேஷனல் மெட்ரலஜிக்கல் லேப். ஸோ அவங்கெல்லாம் ஜோனல் யூனிட் தான். அது வந்து கெப்பாசிட்டி, ஐ மீன் ஃபெசிலிட்டி அதிகமாக இல்லைனாலும் யூ வில் கெட் some minimum facilities with the scientists are there, so they can support you.
And this is a very important technology. It will be most of the buildings hereafter slowly will gain importance.
Yeah. Today it's not that much I mean demand. Maybe everything will take time. Even M-sand also, this M-sand thing we know for 10 years before, 10 even 15 years before. But unless government is not taking action, we will not come. I mean, because once the river sand is banned, means what is the other alternative? So they have to come. So குழந்தைங்க கூட வந்து ஒரு அடம் முடிச்சுட்டு எனக்கு இது வேணான்னு சொல்லிட்டு நம்ம வேற கொடுக்கறதுனால தான் அதை வேணான்னு அப்படி சொல்லிட்டு இருக்கோம். நீங்க அது எனி காஸ்ட் நீங்க வந்து இதுதான் இருக்கு நம்ம விட்டோம்னு வச்சுங்க, கொஞ்ச நேரம் ஆடும், அப்புறம் பார்க்கும், பசி எடுக்கும், வேற வழியில் அதுதான் சாப்பிடும். ஸோ நம்ம அந்த சுச்சுவேஷன் நம்ம வந்து நம்ம கொடுக்காத இருக்கிறதுனால அது கொஞ்சம் அடம் பிடிக்குது, அவ்வளவுதான். ஸோ அதனால இதுக்கு ஒரு டைம் வரும், தென் we have to wait for that.
So the prefab structures is going to be next technology for civil engineers.
Yeah, already precast technology வந்தாச்சு. I mean maybe that what the different technology and தவிர precast வந்து இப்போ அதுதான் மெயின். ஏன்னா இப்போ வந்து we are not having a labors, construction workers யாரும் இல்லை. அப்படியே இருந்தாலும் வந்து அவங்க very they are not trained, so we have to go industrialized based construction தான். அதுதான் ஃபியூச்சர்ல going to be there. ஸோ அதனால இந்த நாலேஜ் கொஞ்சம் தெரிஞ்சு வச்சுங்க. ஸோ எனிவே நான் சொன்ன மாதிரி அகைன் டோன்ட் லோ, ஐ மீன் there are a lot of opportunities are there. ஒன்லி நீங்க கொஞ்சம் ரெஸ்பான்சிபிலிட்டியா இருக்கணும், அவ்வளவுதான். ரெஸ்பான்சிபிலிட்டியா இருந்தாக்கா there are plenty of works. Yeah, sorry, I have taken much of time. I thank you very much for patient hearing. Once again, all the best. Again, Happy Engineers Day. Thank you. Sorry.
Thank you so much, sir, for giving elaborate, knowledgeable lecture, and it is really informative. And I would like to extend my gratitude to Dr. J. Prahabar, sir, for spending a valuable time with us. Thank you, sir. I request all to stand for national anthem.
Nayakan Jaya जाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जय गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all.